Hello, and thank you for joining us. My name is Shai Ofik, and I'm a Lead Technical Product Manager in the Windows Server and Tools Division at Microsoft. Today's session is about deploying Linux guests on Hyper-V, and we will focus on SUSE Linux Enterprise Server. Just a quick view of our agenda. For those of you who are new to Microsoft Windows Server 2008 R2 and Hyper-V, I will provide a quick overview of Microsoft Virtualization Platform. I will then list all the requirements for deploying SLES on Hyper-V and continue to showing you the steps of installing it. The following part will be installing the integration components and thus making SLES an enlightened and performant guest on Hyper-V. We will finish with talking about how this guest, as well as other operating systems, can be managed using Microsoft Management Platform for heterogeneous data centers. When Microsoft first introduced Hyper-V with Windows Server 2008, the key changes in this platform were a very thin and highly performant hypervisor. Hyper-V comes as a feature of Windows Server 2008 and 2008 R2, or as a standalone GUI-less distribution. When enabled on your server, resources like CPU load, memory allocation, disk, and network I/O are now managed by this hypervisor. Hyper-V and virtualization allows you to simplify deployment, improve manageability, increase resilience in your data center, and all with reducing overall costs. If you wish to learn more about Hyper-V, please go to the Microsoft.com/virtualization website. Now let's talk about running Linux on Hyper-V. In the following demo, we assume you have some basic experience with Windows, like using a remote desktop session, utilizing ISO images, etc. We also expect that you have already allocated a system and enabled the Hyper-V role. The SLES ISO can be downloaded from Novell's website. We are using version 10.2. It is certified and supported by both Microsoft and Novell when virtualized on Hyper-V. Links to the Linux integration components, as well as enlightened mouse drivers, will be provided later in this session. With regards to time, on a standard server it takes about 20 to 25 minutes from the moment you connect to start installing SLES until it is fully configured with the ICs and the added drivers. The first step would be using Hyper-V Manager on a Windows Server 2008 R2. You can do this in three ways. On the system itself, where you can simply launch Hyper-V Manager from another server or a Windows 7 client using the Remote Server Administration Tools, RSAT, or via a remote desktop session. In this demonstration, I will mostly use a remote desktop session, but feel free to use what works best for you. So let's begin. The first thing to do is launch a remote desktop session into my Hyper-V server. After logging in, I will launch the Hyper-V Manager. Now let's prepare our server for the first guest. There are a few steps you may want to follow after you have enabled the Hyper-V role. For example, some organizations may have a specific location for data files. Also, they may want to keep the Hyper-V configuration files and virtual hard drives, VHDs, in the same folder. Secondly, with regards to network configuration, you need to make sure your guests have network connectivity. So in our demo here, I will create a virtual switch that will connect to my public network. This way, other servers can access my SLES guest, and the guest can access other systems as well as the internet. If you are connected to the server remotely, making network changes may cause some disruption to your remote session. Now we're ready to create our SLES guest. On Hyper-V Manager, I will launch the new virtual machine wizard. The name I select for the guest may not correlate to the host name or the DNS name of the actual guest, but it is good practice to keep some conformity. I will connect my guest to the public network switch and select the installation from an ISO option. Once we completed creating the guest, we can turn it on and proceed with SLES installation. One of the things you may want to do is maximize the guest window using Ctrl-Alt-Break or from the View menu in Hyper-V Manager. At this point, I can choose the default installation options for SLES. Once SLES setup is ready for input, I can also choose the default options, or alternately, the components that are required for this system. Again, for our demo, I will be choosing the default options. The reason is, I want to show you how to add these components later on, so if you didn't create or configure the Linux guest, or if your organization uses automated build scripts, these will not need to change when you start using Hyper-V. Also, since our virtual machine does not yet have any integration components, we do not have mouse control inside the guest. Later on, we can fix this, but for now, we are forced to use the keyboard. Now, if you really need mouse control during the setup process, there are two ways to fix this. Either perform the initial installation on the server itself, or use Hyper-V Manager from a remote machine, which can be another Windows server or a Windows 7 client. If neither of these is an option, you can simply use keyboard shortcuts as I am doing right now in this demo. Once you have finished making your selection, the actual installation will begin. This phase may take up to 20 minutes, so I'll skip to the point where the system is ready to finalize the setup. After we hit the finish button, the guest will reboot again, and once the operating system loads, we will be looking at the standard SLES login screen. The reason you don't see the whole screen is because the resolution of the SLES guest is higher than my remote desktop session. We can fix this after we log into the guest. So let's log into our virtual machine using the username and password we assigned before. As mentioned earlier, we will not have mouse control inside the guest until we install the integration components, so we'll have to do some things right now with the keyboard. I'm going to scroll down and press the start button of my standard keyboard. The first thing I want to do is fix the resolution so we can see the whole screen as we work. Then I will navigate and launch YAST, which stands for Yet Another Setup Tool. The applet for controlling the screen resolution is called Graphics Card and Monitor, which is on the upper part of my screen. I can simply type it in and tab into it. The next thing I want to do is go to the resolution options and change them. Hitting OK will save the change and give me the option to log out and apply it when logged back in. However, I will go an extra step and reboot the guest so you will see the whole screen, even from the initial login pane. Now before we log back in, I would like to download the Linux ICs from the Microsoft website. I will minimize my SLES guest window and launch a web browser on the Hyper-V server. Obviously, this action can be done from my workstation or even before we begin with our SLES installation. Using a quick web search, we can easily find the IC's download location. But don't fear, I will provide all of the necessary links toward the end of this session. The file we are downloading is a self-extracting compressed ISO image. I am saving it into the ISOs folder on my server and extracting the ISO. Now we can change the screen back to full screen mode and log back in. Before we can install the ICs, we need to add some software components to our installation. We will do this by launching the Install Software application, or YAST. The first component we need is kernel source. I can simply type in the name in the search line, highlight it, and click Install. The second component is GCC, which is the new C compiler. This component has dependencies, and the installer is prompting us to add them. At this point, we can close the installer and continue to install the ICs. So let's switch back from the full screen mode and mount the IC's ISO that we downloaded earlier. As we mount the ISO, you will see that the CD shows on the Linux desktop. The actual installation is performed from a command line interface. So let's launch a terminal window and change our working directory to a temp folder. The next step is to create a directory for the IC's installation files and copy them from the mounted ISO CD. Let's confirm that the files are there. And using the Perl interpreter, install the drivers. As you can see from the messages on the screen, they were installed successfully. Now we can continue to install the mouse drivers. Let's change from a full screen mode so we can download the drivers on the host system. Again, I can use a web search to find the drivers, or simply use the links that are provided at a later part of this session. The mouse drivers are provided in an ISO image, and I will download it to the ISOs folder on my Hyper-V host. I will then mount it on the Linux guest, and maximize the working area. I'll then switch to my terminal window and copy the files from the ISO CD to a folder inside the temp directory. After the files are copied over, I install the mouse drivers using the Perl interpreter. Once the drivers are installed, I can begin using the mouse inside my SLES guest. Now there's one more step to follow, and that requires a final reboot of the SLES guest. Following this last reboot, we will see that mouse acceleration is in line with the host settings, and we will also gain the ability to seamlessly use the mouse inside the guest window or outside of it. Lastly, we will have the ability to chain remote desktop sessions and still have full control of the mouse inside the SLES guest. So let's summarize what we did so far. We installed the SLES10.2 guest directly from an ISO file. Then, we copied the integration components to a local directory, installed them, and then did the same for the mouse driver. This is really all you would need to make a SLES virtual machine operate in an optimal form on a Hyper-V host. Now we can proceed to installing your line of business or other applications. Allow other administrators to control this guest using their domain credentials, maybe enable SSH, install VNC on the system, or integrate it to your Active Directory forest. The best thing to do is simply follow the same standards you have for other Linux systems in your organization. Being that this guest is now virtualized on a Windows host, we can add some functionality and possibly extend manageability through Hyper-V, Hyper-V Manager, as well as Microsoft System Center Suite. These powerful tools can assist you in creating templates of virtual machines, monitor the availability and performance of the guests, as well as the applications running within them. We will go into these features in a future session, and in the meantime you can explore these options at microsoft.com/management. And as promised, these are the links and scripts for all the actions we performed in this session. In summary, we've gone through installation of SUSE Linux Enterprise Server version 10.2 on a Hyper-V host, a component of Windows Server 2008 R2, and seen how it is fully supported on this platform. Then we reviewed how to install the integration components and the mouse drivers. We've also discussed additional methods to administer non-Windows guests on top of Hyper-V. For additional information and resources, please visit our virtualization and management sites and our virtualization team blog. Also, information regarding Microsoft open source initiatives are discussed in our Port 25 community site. And at this point, I want to thank you for joining us in this session. We really hope you enjoyed it.